Yo, what's up guys? In this video we'll be doing the question 1 of the KZN March 2025 common paper. Let's get on to it. Given the sum to n terms of an arithmetic sequence, which is this, now first thing you need to realize is that this equation, this sum, came from the formula Sn is equal to n divided by 2 into 2a plus into n minus 1 d. Right? You have to understand that. The fact that they know what the sum is represented by means they use this formula. It's not that it's going to be useful, but you have to know it. Now let's get on to question 1.1. Question 1.1 says calculate the sum to the sum of the first 21 terms of the sequence, right? So if you were given a sequence and you had to calculate the sum, like they gave you the first term, the second term, and so on, you would use this formula. You would find the difference, you'd write the number of the term that you want, you'd write the first term, and you'd write the number of the term that you want, right? Now, they have already substituted all the other things. The only thing that is left is n. That's why we have this formula. This formula basically means they've substituted d, they've substituted a, they've simplified, and the only thing that is left from you is to put n. You just need to substitute n and you will get the sum. So that's what we're going to do now. So the formula is Sn is equal to 3n squared minus 5n. Let's do that. We're looking for the sum to 21 terms, right? So 3 into 21 or squared minus 5 into 21. So the sum to 21 terms is, we go to the calculator. I've actually done this. Let me just check my answer from before to make things faster. It's 1218. Now the next question is, okay, this is the answer, this is the final answer, this is the sum to 21 terms. Determine the 22nd term of the sequence. The 22nd term of this sequence. How we find that is, we find, okay, we want the term at position 22, ne? So we find the sum to 22 terms. Since we already know the sum to 21 terms, right, think about this. In order to get from the sum to 21 terms to the sum to 22 terms, you have to add the 22nd term, right? Because you keep adding the terms to get the sum. So, in other words, if you take the sum to 22 terms and subtract the sum to 21 terms, you will get the 22nd term. Okay? So, now what we are going to do here is, on question 1.1.2, we will say that T22 is given by, which is the 22nd term, which is what we're looking for. It is given by the sum to 22 terms minus the sum to 21 terms. We already know this, so let us substitute for this. How do we sub for this? Well, for the sum to 22 terms, you take the original formula, this one, Sn is equal to 3n squared minus 5n. You substitute 22 here and 22 here on the place of n, since n is equal to 22. If you substitute 22, we're going to substitute here though, and then you subtract the sum to 21 terms. So it's going to be 3 into 22 squared minus 5 into 22. Okay, this is just a substitution for that. It represents sum to 22 terms. Now we are subtracting the sum to 21 terms, which is this one. This is the answer for the sum. This is equal to this. So we subtract 1218. You could do this separately. You could find the answer for the sum to 22 terms first and then subtract at the end. That would be better. t22 is equal to this. We're gonna say now 3 into, okay, we're gonna do the first half first, and then we'll write the next answer, just in case there's a mark for this answer, né? But I don't think so, since it's only 2 marks. We'll say 3 into 22 all squared minus 5 into 22. That gives us 1342. We subtract this 1218, and we should get our term number 22 to be 1218. It's 124. Okay, that's it. We wanted a 22nd term. We took the sum to 22 terms, subtracted the sum to 21 terms, and we got our 22nd term. Now we are going to question 1.1.3. Question 1.1.3 says you have how many terms of this sequence must be added to obtain the sum to this number of terms. Don't know how to read. How many terms of the sequence must be added to get this? So what they mean is, this is the sum, this is the answer you get when you add a certain number of terms, né? This is the answer you get. This is SN, it's the answer you get. But they are asking how many terms do we have to add to get that answer. So that's N. N is the number of terms you have to add. So basically we have SN. SN is this. We just need to sub SN here and solve for N. So what we are going to do is write the formula, but we're going to say 3n squared minus 5n is equal to SN. Right, it's the same formula as the one there, but now I said SN this side, I wrote SN this side. Say 3n squared minus 5n is equal to, now we substitute in the place of SN, we put 8162, because that is the sum, that is the answer, 8162. And then we solve for n. How we solve for n here is we first transpose this to that side, or you could say you subtract it from both sides. It's the same thing. 3n squared minus 5n minus 8162 is equal to 0. Now you could try factorizing this. There is definitely a way to factorize it, but to save time, let's use the general quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So, but now we are not looking for x, we are looking for n. So I say n is equal to b. B is this term right here. B is this term, which is negative 5. So negative from the b into negative 5 for this value, since it's negative 5, plus or minus the square root of b again is negative 5 squared minus 4. A is 3. C is this value, which is negative 8162. You have 2 into 3, since your A is 3. Now n is equal to, you could try to simplify this, but yeah, I don't think it's necessary to try to do that. The answers I get when I press this on my calculator are 53, or n is equal to negative 51,33. Right, but n cannot be equal to this. Why? We have two reasons. The first one is n cannot be negative, it has to be positive. And the second one is n cannot have commas, it has to be an integer. An integer is all positive and negative counting numbers along with 0. So since it has commas and it's negative, it's a wrong answer. Now what we do is, so these you'd say are our critical values. Now we can say therefore n is equal to 53, and you can say and here, or you can say but n is not equal to negative 51,33. There's usually a mark for saying this, so you have to say what's the n is not equal to the other value. And that is our answer. That is our answer for question 1.1.3. Now let us move on to question 1.2. This is 1.2. 1.2 says consider this sequence. Then they say determine the value of the 78th term of the sequence. Right. I want you to realize something here. My marking pens are close. So if you look at this sequence, there is 12, 17, 22, and they are divided by 7. There's a 7 here, and it's divided by 7. So this to me looks like it's two series. One series is just saying 7, 7, 7, 7. That's the first one. That's the simple one because it will always be 7. The second one is 7, 12, 17, 22. Okay? That's the second series. Now, let's check what type of series this is. I don't think there's a number you can multiply 7 with to get 12 and take the same number and multiply 12 with to get 17. So it can't be a geometric series. Ne? Can't be a geometric. Let's see, this is 7, this is 12. To get from 7 to 12, you add, right, wait, let me show you what I'm doing. So I just don't, we have to check whether it's a geometric, it's an arithmetic, it's what's the quadratic, or any other. So for this, we already know it's not geometric because there's no answer you can multiply 7 with. Okay, you can just do this. You can say 17 divided by 12, get an answer, and say 12 divided by 7. Those answers should be equal for it to be a geometric sequence, but they won't be equal, so it's not it. Let's check the arithmetic one. From 7 to 12, you add 5. From 12 to 17, you add 5 again. From 17 to this, you also add 5. So this is an arithmetic sequence. Automatically, it's not this. So let's check how we can find the value of the 78th term of the sequence. Firstly, this is the first term, second, third, fourth, fifth, sixth, seventh, eighth. Right. Now the first, third, fifth, and seventh are odd. They are odd. All odd numbered all odd numbered positions of terms are 7. So 21 is 7. Term number 21 is 7. Term number 101 is 7 because it's odd. It's not divisible by 2. Term number 1045 is 7 because it's not divisible by 2. But all the others, they use the sequence for 7, 12, 14, about 7, 12, 17, and 22. Let me write the sequences because sometimes they have marks for that. So we have the first one, sequence 1, which is 1, which is 7, 7, 7, and so on. We have sequence 2, which is 7, 12, 17, 22, 7, 12, 17, 22. Now, let's see a pattern here. This, according to the original sequence, is term number 2. This, according to the original sequence, is term number 4. And this, according to the original, is term number 6. And this is 8. Right? So, according to this sequence, this is term number 1. According to this sequence, this is term number 2. According to this sequence, this is 3. According to this sequence, this is 4. Notice something. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6, and so on. What does that mean? On the full sequence, whatever number you have, whatever whatever n you have, you divide it by 2, since we divided this by 2, to get the number of the value of like which n is it on this sequence. So what we're gonna do to solve this problem now we're solving, we're gonna say we want the value of the 70th term on the original sequence. The 70th term should be 78 divided by 2 on this sequence, which is should be 30 something, 37 or something. 78 divided by 2, 39, right? 39. I should not be lazy to calculate with my head. I should start being serious. Okay, this is 39. We are looking for term number 39. I hope you understand. We are looking for term number 39 according to this sequence. But according to the original sequence, it's term number 78. So we are going to take this. We are going to find Tn for this. Or not, we can do it another way. After finding that, we can substitute 39 on the Tn, and we will be set. So term number 78 of the original sequence should be equal to okay, let me say sequence 1 here, sequence original, sequence O, should be equal to term number 39 of sequence 2. Right, understand that these are just to show you guys which sequence it's on, but generally I think if you write T39 it's fine. It's equal to, now remember the equation for Tn, it's a plus, it's Cn is equal to a plus into n minus 1 d. So we say a plus into n minus 1 d. Do we know a? First term 7, yes. Do we know n? Yes, 39. Do we know d? It's the common difference. We already proved it's 5 because I said to get from this to that, so it will be 5. But let's just, for good sake, for whatever that is, 5. Now, the first term is 7, we're substituting, plus the n is 39 minus 1, d is 5. Let us find the answer. 7 plus into 39 minus 1 is 38 times 5, which is 197. That is your answer. That is your final answer. That is your final answer. Oh, this is question 1.2.1. Let's go to the next question. The next one says, calculate the sum of the first 103 terms of this sequence. Once again, we separate the sequences. We already did that. We are doing question 1.2.2. The sum of the first 103 terms. 103 terms. what you notice is the 7s are just going to add together. It's just going to be 7 plus 7 plus 7 plus 7 up until we get to this. But for sequence number 2, we need to use the sum for an arithmetic sequence, which is, where is it? This one. We need to use this equation to find the sum to this. But before we use that, we need to find out how many terms of the second sequence we need to add and how many terms of the first sequence we need to add, because we need only 103 and they are divided between the two sequences. Now, this is an odd number. Which means that the last term will be a 7. It will be in the sequence that has 7, 7, 7, because I said all odd number value of terms are 7. So it will be in the 7 one. But if we go one less value than this, we will have 102. Okay, 102 is the position of this term, of the term that uses this sequence. So if we divide it by 2, we will know how many terms in this sequence we need to add. If you divide this number by 2, you will know how many terms in this sequence we need to have, since this is an even number. So we're just going to divide that by 2. What you get when you divide this by 2 is 100 divided by 2 is 50. 2 divided by 2 is 1, so it's 51. But for goodness sake, 102 divided by 2 is 51 terms, right? So we are going to add 51 terms in this sequence, but how many terms in the other sequence are we going to add? Now imagine it like this. The first term is a 7, right? The first term is a 7, which means it's going to be 7, a number. Okay, how am I going to show this? How can I show this? But the other sequence should have one more. It should be 52, because, okay, yeah, this is an easy way. You say 103 minus 51, it's 52. Simple. Yeah, that's an easy way. There are many ways to explain it, but this is the fastest way to get to the answer, it seems. So for the 7s, we need 52 7s. 52 7s. This is not an answer. This is just me trying to explain. Right, now let's get to the answer. For this, we're gonna say Sn is equal to n divided by 2 into 2a plus into n minus 1 d. Then for the 7s, we're gonna say plus. Remember, I just said it's just gonna be 7s, so it's just gonna be 7n, right? So it's gonna be 7n. Let me say n1 here, and say n2 here. It's the sum. Hope you don't get confused. I said 2 here because this is 52. I said 1 here because this is 51. But we are looking for the sum to 103 terms, right? We're looking for the sum to 103 terms. We're gonna add the n1 is going to be 51 divided by 2 into, for the a, we have a 7 plus into n minus 1. 51 minus 1 is 50. Then d, remember, is 5. It's the difference, plus 7 into n2 is 52. Sum to 103 terms is equal to, let's say, 51 divided by 2 into 2 into 7 plus 50 times 5. Wait, what? Okay, yeah. I have 6, 7, 3, 2 plus 7 times 52, which is 364. So sum to 103 terms is actually just 6, 7, 3, 2 plus 364, which is 7096. I don't know how to say numbers. I don't know how to say numbers. I'm not an accounting student anymore, but I used to be an accounting student, a reasonable one. Maybe one day I will make a video on accounting. Okay, done. We are done. We did this. We did all of these questions. If you have anything you don't understand, I have my email on the channel description. There's my email there. You can email me something you don't understand. I will definitely make a video on it, explain it, make sure you understand. Make sure to give this video a thumbs up, share it, subscribe to the channel. Thank you for watching.